All right, welcome everyone. It's 11, so I'm going to go ahead and get started. Good morning, everyone, and welcome to the March California-Nevada Drought Early Warning System Drought and Climate Outlook webinar. Thanks to those of you that have joined us previously and are joining us again, and those joining us for the first time. My name is Amanda Sheffield, and I'm from Scripps Institution of Oceanography in San Diego, and I'm moving into the role of the Regional Drought Information Coordinator for NIDIS for California and Nevada. This is a part of our bi-monthly webinar series that are designed to provide the region with timely information on current drought status and its associated impacts, as well as a preview of developing climatic events. I'll note that this webinar is being recorded, and all of its slides and a two-page summary will be on drought.gov later this week. Before we get moved into our topical presentations for the day, I was just going to go a little bit over NIDIS for those that haven't joined us before. NIDIS is the National Integrated Drought Information System. They provide a better understanding of how and why drought affects society, the economy, and the environment, and they're improving the accessibility and information of early warning information. They are doing this through building off a network of regional drought early warning systems to create a national drought early warning system. And here in California and Nevada, the drought early warning system utilizes our new and existing partner networks, which is a wide range of expertise from federal, tribal, state, local, and academic partners, as well as to make this information available, easier to understand, and usable for decision makers. Specifically to here in California and Nevada, we originally had a California DEWS set up around 2010, and we've now added Nevada with its specific interests following Governor Sandoval's drought forum in 2015. And we have a strategic plan that's underway to focus on what goals we have for NIDIS in the region. Now to get back to today's webinar, we try to keep these topical with things that are going on specifically related to our water year, when we receive our precipitation, and when we start to see drought. So first off, we're going to have Dan McAvoy from the Western Regional Climate Center talk about the drought and climate status update and how this precip we've seen so far this year has affected the drought and climate. Julie Kalansky, also from Scripps and CNAP and CW3E, will be doing the outlook, including some stream forecasts and more shorter-term forecasts than we usually have shown, followed by Justin Huntington doing observed changes in vegetation and spring-summer outlook. With that, I'm going to pass it over to Dan, if you're ready.
Yep, all set.
And I will mention we're going to save all questions and answers for the end, unless we have some quick questions per speaker, but generally we'll keep them all for the end. So go ahead and enter those in the questions box. And go ahead, Dan.
Thanks, Amanda. Could you guys see my screen and hear me right now?
Yes.
Okay, great. Thank you. Well, thanks for the introduction, Amanda. My name's Dan McAvoy. I'm assistant research professor of climatology at the Western Regional Climate Center at DRI, and today I'm going to be giving everyone an update on what's been going on this water year with the drought, and also what's happened the past 2 months since we had our last webinar. So this opening photo is from Mojave Trails National Monument down in one of the Southern California deserts from mid-March. And this is, there's been huge wildflower blooms in the Southern California deserts. And as you'll see as I go through the presentation, that's largely due to heavy precipitation during parts of the winter, then followed by a rapid warm-up. So then there's been these really beautiful, phenomenal wildflower blooms over the past month or so. So I want to start out by giving sort of the broad overview of the drought conditions, which I tend to think of as the U.S. Drought Monitor. And so this was the latest U.S. Drought Monitor map that was updated last Thursday. And so you can see statewide, this has been a common theme all throughout this winter. The drought has been greatly reduced throughout the state. Currently, there's only a total of about 25% of the state that's in drought, and some of that's D0, and there's a few small areas along the southern California coast and down into the southern part of the state that are in D1 and D2, and some of that has to do with some of the reservoirs aren't in great shape still down in that part of the state, and also groundwater issues that we don't really know enough about yet to say how the groundwater will recover. So this next map is showing how much the drought monitor has changed over the past 2 months, basically about the time since our last webinar. And so from January 24th through March 21st, there's been continued widespread removal of drought classifications, 1 to 3 classes removed. At this point, in the north, there hasn't been much change because much of the drought was already removed earlier in the winter. So again, throughout the entire winter, there's been huge degradation of drought throughout the entire state of Nevada, California. So next, I also wanted to show Nevada. Nevada really almost has, well, not really, almost. They actually have no drought categories left in the state. The little patch of yellow there is abnormally dry, or D0, which isn't considered a drought category yet. So that's great to see. So Nevada is doing very well also. And if you look at the changes, there's been fewer changes. Nevada had sort of more removal of drought earlier in the winter as well. But in the past 2 months, there's still been 1 to 2 category improvements in central and western Nevada. So continued removal of drought, which is always good news for after so many years of long-term severe drought in the region. So I wanted to move into now why sort of the drought monitor has been changing throughout this winter, and more recently we'll start off with the precipitation. And so this is sort of covering the past 2 months since the last webinar. On the left is the February percent of normal precipitation. And so if you focus in on California and Nevada, it was pretty wet for much of the state, very wet for the Sierra Nevada, north central California, and the northern part of Nevada. A bit drier as you get into some of the southern California deserts and southern Nevada, but overall, February was very wet. And on the right is March 1st through the 26th. And so as you'll see, March has been quite a bit drier compared to what January and February saw for much of California and Nevada. The north and the northern Sierra is sort of slightly below normal to near normal in a few locations, but mostly slightly below normal. And then Southern California and Nevada have been very dry for March so far. So overall, March has been much drier than the previous 2 months. So I did want to point out, so this is the October through February. So these are monthly maps that are updated by the Westwide Drought Tracker. If we waited about another week, we could add March in here, but we don't, since it's still in March, we don't have that map available yet. So this is the October through February precipitation percentiles. So these are the rankings based on PRISM going all the way back to 1895. And so what we'll see here is that there are large areas of California and Nevada that have seen their record wettest October through February on record. So this is pretty big, going all the way back to 1895. That's a pretty big record to break. So very, very wet water year. And I took a peek at some of the stations like Tahoe City around Lake Tahoe to look at basically October through March. So March has been, as I mentioned, near normal, slightly below normal. And if you consider the most recent data, most of these locations are still on record through March. And so this map shouldn't look a whole lot different once we get the March data in there. A lot of these locations are still on track for record wet October through March as well. So when you take this statewide averages, this is the statewide October through February precipitation totals for California. And so the farthest on the right is 2017, and actually a couple inches above the last previous record, which was 1969. And so a very wet year statewide. Again, going back to 1895, the wettest on record for California. Very impressive precipitation totals this year that have really ameliorated a lot of the drought conditions. And then the same thing for statewide average for Nevada. Still a record October through February. And the previous wettest year is, about less than half an inch above for Nevada, but still very wet, record wet October through February for Nevada. So why has it been so wet? Well, a lot of the moisture we've seen has been from these atmospheric river storms, and this is a really nice graphic that was put together by California DWR and also Scripps combined together to help to make this graphic. And this is showing all the atmospheric river landfalls from October 1st through February 16th. You can see there's just been a ton of atmospheric rivers well above normal, the quantity for this time of year, or for the year. So above normal number of atmospheric rivers. I've highlighted that since the last webinar, there were still 3 major atmospheric rivers in February 7th 10th, and 15th. And so these storms have contributed hugely to the precipitation totals. They've brought very heavy precipitation, rain, and snow. And as I'll show later, the snowpack's in good shape, but it also brought some higher temperatures and higher elevation snow levels with them. So most of the record precipitation is due to these atmospheric river storms. So let's move on to temperatures. And so this is showing the water year, October 1st through March 26th, temperature departure from normal. And so again, if we focus in on California and Nevada, overall, it definitely wasn't a cold water year, despite how stormy it was. The northern part of California and Nevada was a little bit cooler than average, but definitely not cold. And as you shift further south and east in the southern parts of both states, it has been quite warm. And so, as I mentioned, many of the large storms we saw were atmospheric rivers, and those were associated with warm subtropical moisture and higher temperatures and higher snow levels. So the precipitation was welcome, but it also brought heavy rain to some of the lower elevation mountain locations. I also wanted to talk about new drought index, the Evaporative Demand drought index that was developed by myself and Mike Hobbins and others at DRI and NOAA in Boulder. And so this map is showing the 6-month eddy, basically October through March. And so the eddy is driven by temperature, humidity, wind speed, and solar radiation. And so it's not just a temperature-based evaporative demand. And so the blues are indicating not just cooler, but more humid, more cloudiness, more stormy weather. And then the reds indicate warmer, but also drier, more clear sky, and typically higher winds. And so this looks similar to the temperature map on the previous slide, but it doesn't look exactly the same. Okay, the demand has been much below average, so it's been a lot much lower and bluer in the northern part of the state, and then the demand has been much higher once you get east of the Sierra in parts of Southern California and the western Nevada deserts. And one thing to point out, if you look at the previous slide, the temperatures are well above normal throughout all of Southern California, but when you look at the eddy, there are some areas of blue that show up where there have been warmer temperatures, so temperature is not dominating the whole signal here, and what we're seeing is the impacts of more storminess and humidity leading to these bluer or these cooler eddy values. And so this is something we're still developing into an operational product, and I've added some links there where you can find some of these maps and data. So next I want to move on to the snowpack, which of course is so crucial for the water supply in California and Nevada. And so these are the SNOTEL basins. This is the percent of average from March 26. And so basically, there isn't a single basin in California or Nevada, and these are only the eastern Sierra basins that is below 100%. Everyone is above 100%, excellent shape. And as you go further west into the eastern Sierra basins, all the eastern Sierra basins are at 200% of normal or above. The Tahoe Basin is all the way up at 218% of average for this time of the year. So very impressive snowpack still in the Sierra. I wanted to shift, so these are the 3 basins now from California, which aren't really represented in the SNOTEL basins that I just showed. So this is the top is the northern basin, the middle is the central, and the bottom is the southern. And these are the SWE accumulation graphs starting December 1st going through the end of July. The shading, the sort of light blue shading is the average, and then the dark blue is this year. And so you can see in all 3 basins, we're well above normal snowpack. I do want to point out that we really aren't even close to the 1982-83 maximum snowpack, which is well above where we're at right now. And part of that is largely due to sort of the warmer temperatures and higher snow levels that we've seen. We've had record precipitation, but we're not seeing the record snowpack right now, even though snowpack is still in excellent shape. Statewide average, 163% of the April 1st average, which we're very close to April 1 right now. I will note that we had sort of a first peak showing up sort of in early March, and then we did get a little bit of melting in most basins, but the last week we've had a few small storms, and that's boosted the snowpack a little bit, which is great to see it climbing again before April 1st. I did want to show more of a historical perspective. This is something I put together using the California snow courses, which are manual measurements made on about the 1st of each month. Again, if this was a week later, I could have the April 1 data, but right now I'm showing the March 1st data. And so this is what I'm showing there on the left is the statewide March 1st percent of normal snowpack based on an average of the 58 snow courses shown on the right. And this is going all the way back to 1950 through 2017. So as of March 1, the 2017 ranking was 6th. So it was the 6th greatest March 1 snowpack going back to 1950. And then 1969 was the champion there at close to 250% of normal. But again, we had record precipitation, but we're definitely not near record snowpack due to sort of the warmer temperatures, higher snow levels, but we're still in great shape with snowpack and water supply. And a little bit more about the water supply. We'll talk about some of the selected reservoirs that this is from DWR, California DWR showing. And so what these graphs show is basically each one of the buckets there shows the blue is sort of the percent of capacity. Well, the full bucket is total capacity of the reservoir. The blue is the percent of the capacity, and then the red line is the percent of the historical average. And so to summarize statewide, every single reservoir with the exception of 2 there is right near or above the historical average, which is great. The 2 exceptions are Millerton Lake, which is at 57%, and Lake Paris, which is at 53% of average down in Southern California there. And again, these are all heavily managed water systems, and so they don't truly reflect the natural variability, but if you looked at this a year ago, all these reservoirs were not nearly as in good shape as they are right now. So this is great news for California water supply. And I wanted to talk about Lake Tahoe, which supplies water to the Tahoe Basin and then a lot of northwestern Nevada up here in Reno as well. And so this is showing the Lake Tahoe, basically the elevation going back to the beginning of the 2010-11 water years, the last time we had Lake Tahoe really fill up to almost full there at a little bit above 8 feet. And you can see that the big drought years there, we went well below the natural rim starting in 2014, and it stayed there for a long time. And if it's below the natural rim, there's no water flowing into the Truckee River. And so it came up again last summer, which was nice because we had sort of an average type of winter. But then last fall, the lake went back below the natural rim again. And so there's been really a phenomenal gain in height in Lake Tahoe elevation since the fall, where it was below the natural rim, and now it's back above 7 feet, which is huge. And it is projected to fill without any problems to a maximum capacity this summer. And there's so much water going to the lake that they've actually been releasing flows into the Truckee River for the last month or so, maybe even a little longer, which is fairly uncommon for this time of year. They usually hold off until late spring or summer to start releasing. But since there's so much snow still and so much rain from those atmospheric rivers that fell into the lake, they've been needing to release. And so this is projected to be the largest single season rise in Lake Tahoe since the records began in about 1900. So very good news for water supply in both Western Nevada and California as well. And finally, I just want to show this graphic that I've been showing that Mike Dettinger puts together. And this is the reservoir plus snowpack. And this is basically, the graphic is showing the blue shading there is the reservoir normal, the average capacity of in millions of acres of feet, the reservoir normals, and then the gray shading is the reservoir plus snowpack normals, and then the dark orange is this year's snowpack plus reservoirs, and then the dark yellow is this year's reservoirs only. And so a few things to point out, the reservoir plus snowpack is well above average. That orange triangle there is 2011, which we're getting close to, but I don't know if we'll quite get there. And then the star is 1983, which we're not definitely going to reach that by April 1, but still well above average. And we've got a little bump over the last week there, which is good. And then the reservoirs are hovering right around average and getting close to those same values for reservoirs that we're seeing in both 2011 and 83 as well. And I think that was about all I had. I have some sort of key points here just to wrap up. So based on the U.S. Drought Monitor, of course, we've seen huge improvements throughout both Nevada and California, largely due to the record precipitation that we have seen from these very powerful, very wet atmospheric river storms. Snowpack is in excellent shape, but we are not seeing record snowpacks due to the warmer temperatures, higher snow levels, less snow at lower elevation. And overall, the summer surface water supply is looking to be in great shape, and it really shouldn't be an issue for most of California and Nevada, which is great to hear because we haven't had to not worry about surface water supply in a number of years now. And that was all I had. So thank you. And
all right, thanks, Dan. I'm going to steal it away and pass it now over to Julie. But while I'm doing that, we had one quick question you might be able to answer. The question was, a year with 4 to 6 ARs is considered normal or even wet. How do we explain 30 ARs?
I definitely cannot answer that question right now. It's an anomaly in the amount of atmospheric river activity that we've seen. And it wasn't really at all forecast in like the seasonal forecast models. We were in a weak La Nina or very close to ENSO neutral. But when you look at some of the scatter plots of the type of ENSO that we were in and where we're at, those other years similar to that have also been very wet. And so, but again, I can't completely answer why there have been so many atmospheric river storms this year.
All right, thanks, Dan. And here's Julie.
Thanks, Dan. I'd also add to that for Northern California, 10 to 11 is probably more typical of a normal year. So 4 to 6 is probably more representative of Southern California, and those 30 are for the entire state of California. So although it's been exceptionally wet and we've had quite a few ARs, I think we have to remember what we're comparing against. But as Dan said, what caused this year to have so many ARs is still very much an active area of research and something we're looking into. But it doesn't necessarily align with what the traditional thinking has been when it comes to ENSO, which I'll touch on at the end of this presentation. So with that, I will start my presentation. My name is Julie Klansky. I'm here at Scripps Institution of Oceanography, and I'll be doing the Climate and Drought Outlook, and I'll really be touching on 3 main topics, which are highlighted at the top of the screen. So the first one is snowmelt and looking at some stream flow forecasts from snowmelt from various different agencies. And then looking at temperature forecasts primarily for summer, because that's what we're thinking, and also for spring and how that may or may not impact snowmelt. And the last one are the ENSO forecasts, which we more traditionally have done on this Climate and Drought Outlook. So I'm starting off where Dan left off. And so this top figure is the figure that Dan showed for the Western Sierras, where the blue is the normal for reservoirs, the yellow is the current, and the red dots over here in the picture indicate the reservoirs that are used to do the sums. And then the orange line is the snowpack. And as Dan mentioned, the upward triangle is 2011 and the star is 1983. And as Dan said, this has been a great year for precipitation and for snowpack, though we might not reach 2011, and it is very unlikely that we'll reach 1983. And this figure is produced by Mike Dedinger, and here's a link where you can get it as he updates it. He posted here on the CNAP website, so this is a link where you can access the updated version as they come out. Down below is a relatively new figure that Mike Dedinger and a colleague at DRI has put together, where the blue is Lake Tahoe normals, and the blue line, the cyan line, is the current storage in Lake Tahoe, and the orange line is the lake storage plus snowpack for the Lake Tahoe region, which is indicated in the figure by a star. And the dashed lines are the 1983 values, just for comparison. And so again, as Dan mentioned, this has been a great year as far as water supply in the Tahoe region. I should note that the top figure was updated just yesterday, and the previous figure was updated March 19th. So the timing of them isn't exactly the same. So now that we have all the snowpack, the question is what's going to happen to it? And that's what the next couple slides will address with the stream flow forecast from different agencies. So this figure is from DWR's Bulletin 120 report. And so as of March 1st, these are the percentage of normal of snowmelt runoff in the various basins throughout the state. And as you can see, almost all the basins are, all the basins are well over 100%. Some are over 200%, with the Eastern Sierras having a higher runoff potential than the Western Sierras. The one thing to note is the figure that's shown here on the right only comes out monthly. However, they do weekly updates, and the red two values in the Southern Sierras are the most recent update as of March 23rd, and there was quite a decrease in the streamflow forecast between March 1st and March 23rd, whereas the other basins didn't have quite as much of a decrease. Most of them decreased by about between 5 to 10%, whereas the two Southern Sierra basins decreased by about 25%. So there is quite a bit of snow and quite a bit of runoff that will come from it. And now the question is when, which is highly temperature related, and we'll get to shortly. So in looking at the Eastern Sierra Nevadas and in Nevada, the NRCS produces a monthly stream flow forecast, which is highlighted here. The table at the bottom, so what you're looking at, what you're looking at is the estimated, so for example, 90%, there's a 90% probability that the stream flow forecast will exceed 619,000 acre feet. That's for this first box right here. And so if you read sideways, for the second box, it's a 70% exceedance probability, or 70% chance that the stream flow will exceed 697,000 acre feet. So that's how you would read this table. And what the yellow is showing is that it's greater than 2011. The pink is showing that it's greater than 1983, and the red is showing a new record in the stream flow forecast from snowmelt. And I should note that these are forecasted from April through July, so this is not in just 1 month. This is over the entire melt period. And on the figure on the left, I tried to highlight where some of these different points were. So the Humboldt River is up towards the north, the East Fork and the West Fork, Carson River, and then this is at Carson City, and this is the FC is Fort Churchill. So you have a sense of where the table is reporting for some of these stations. Oops. Okay. And then because throughout California, Nevada, we often rely on the Colorado. I wanted to look at the Colorado inflow forecast. And so this is from the U.S. Bureau of Rec. And what you see are historically, or all the blue lines, are the April through July forecast. This most recent one was issued March 1st. And so the lowest orange line is the minimum probability, and it's 7.6 million acre feet. The red line here, if you can see my pointer, is the median probability, which is 10.4 million acre feet, or 145% of normal. And the highest, or the max probability, is 13.8 million acre feet, or 193% of normal. And so this is the possible range that the U.S. Bureau of Rec is forecasted for inflow into Lake Powell. As I mentioned before, part of what matters for snowmelt would be temperature, because if there's a substantial warming throughout much of the region, it can cause the snow to melt more quickly. And so I'll be looking at the 7-day forecast for temperatures, and also the monthly forecast from CPC and the NNME. So for the next 7-day forecast, what we see is that the Southern Sierras in particular show that they indicate that they'll be much warmer than the climatology or the historical average for this week, from 8 to 16 degrees, depending where you are. There's some of these hot spots where it would be much warmer. Whereas parts of Tahoe will be slightly warmer, about 0 to 4 degrees. There's one spot that will be 4 to 8 degrees based on this forecast. Okay. However, if you look at the April forecast from the NNME and from CPC, so the figure up on the left is the NNME. It's a ensemble multi-model, North American multi-model ensemble. So it's several different models that do a dynamical forecast to look in to protect monthly to seasonal out to a year. And so this is just for April. And the white region is indicating that there's, relative to climatology, it does not appear to be warmer or colder. It's just about average or within that range. The figure on the right is from NOAA, and this is looking at temperature for April as well. They do it slightly differently. It's the probability of exceeding normal temperatures. And so as you can see, for much of the state, it's white, which indicates there's no increased probability of above normal temperatures or below normal temperatures. So now going a bit further ahead, thinking about the next 3 months, so spring, April, May, and June, these figures are very similar to what was shown before. It's just for the 3-month forecast. The gray areas on the NNME map shown in the upper left are areas where the NNME forecast has not been shown to have any skill, and so it doesn't do better than climatology, and so that's why it's grayed out. But for the areas where it does show to have skill, it's indicating that these spring months, April, May, and June, will be about 1/4 to 1/2 degree higher than climatology, and this is for the Eastern California and quite a bit of Nevada. And then in looking at the CPC forecast, it's showing a similar trend in that there's a 34 to 40% probability of above normal temperatures in Southeast California and Eastern Nevada. So for the next season, or the summer season, looking at temperature forecast, they're all showing above normals in probabilities of getting quite possibly even higher above normal. So the NNME for much of the eastern part of California and quite a bit of Nevada is showing 0.5 to 1 degrees higher temperatures. And then parts of the very northern parts of either of the two states are showing 0.25. I realize this is a typo. It should say 0.5 degrees Celsius higher in Nevada and California, and it's in the northern parts. And the CPC forecast agrees in the sense that it's suggesting that there's a higher probability of above normal temperatures, 50 to 60% chance in southeastern California and southeastern Nevada, and then a 40 to 50% chance or probability of above normal temperatures in California and Nevada. And then as part of our region can be affected by the summer monsoons, I wanted to show the precipitation forecast, but if you look at it, there is actually no skill in forecasting the monsoon regions. And so that's why this area in California and Nevada is all graded out, is the forecast isn't any better than just climatology. So, and then going on to the last part of the presentation, we'll look at the ENSO forecasts. And so this is currently the SST conditions over the last month, so as of March 18th. The central equatorial Pacific is about normal, just slightly cooler, between 0 and 0.5 degrees. We've recently seen this warming in the eastern equatorial Pacific, which is seen over here from about 1 to 2 degrees, and off the coast is actually much warmer from 2 to 3 degrees. And then looking at the forecast for ENSO, So the months are down at the bottom. This is February, March, April, May, and so forth. And this is the probability of the different phases of ENSO. And blue is La Nina, green is neutral, and red is El Nino. And as you can see, as we go forward in the year, by about fall, so July, August, September, and into fall, the probability of El Nino is increasing, and which some of the news media is starting to pick up on, and you'll hear about this. In the next slide, this is looking at the various different models that do El Nino forecast. There's some that do it dynamically, so they have models that that calculate and change with winds. And so these are the solid color lines, and the ones that are open are statistical models. And again, this shows by about August, September, October, the ENSO conditions are possibly going to be returning. And I should caution, we're very early for this, and so these forecasts are likely to change and may change, but just be aware that this is where the current forecasts are looking. And I should note on all these slides, and in this one in particular, most of these forecasts are updated regularly, and there are links to where you can find this information if you would like to find it in between outlooks or just on your own. You can find it by using the links on the slides. And so even with the ENSO forecast, this is a figure that I've put together. So this is looking at the ENSO strength based on the oceanic index, which uses sea surface temperature in the tropical Pacific. And on the left side, there are La Nina-like conditions, and on the right side, there are El Nino-like conditions. And this is for Southern California DJF precipitation. And as you can see, so Southern California is one of the regions that has, of any region, that has a stronger relationship with the ENSO index. But recently, what we would expect from ENSO hasn't held up. And so I tried to highlight that. For example, 2011, prior to this year, was one of our wetter years in our recent past. And it was in a La Nina period, which is typically, prior to that, had a tendency to be drier. And then 2016, which was last year, as many people know, was a very strong El Nino, but the precipitation, especially in Southern California, wasn't very high. Whereas this year was a very weak La Nina, which is 2017, and we've had an immense amount of precipitation. And this is just for Southern California. And so that's, as Dan showed, this wasn't a record-breaking year in Southern California, but it was a very wet year. And so this is one of these questions, and it's still very much an active area of research, but is the ENSO and precipitation relationship changing in the region? And I don't think anybody has a very good answer for that, but as I said, people are interested in this and researching this currently. The one thing I do want to note is, especially for those people living in coastal communities in California, that even though we're not the ENSO precipitation relationship hasn't held to traditionally patterns that we've seen in the past, ENSO does influence sea level extremes. And so this is a figure that was put together by Dan Cannon and Laurel DeHaan, where it shows the percentage of extreme sea levels during different phases of ENSO. And so as you can see, the strong El Ninos is where there are quite a few extreme sea level events. And even weak, moderate El Ninos events, we have a tendency in coastal areas in California to have more extreme sea level events than in neutral or La Nina conditions. And so with that, here's the summary. There's lots of snowmelt and runoff and record-breaking parts of in Nevada. The next week's forecast are to be warm in southern Sierra Nevada mountains, and this may have impacts on snowmelt in the region. The extended range forecast, however, do not indicate warm temperatures in April. They do indicate warmer than normal spring temperatures, being April, May, and June in eastern Nevada and southeastern California. And they do indicate warmer than normal summer, June, July, August temperatures in much of the region. And there's just no scale currently for the monsoon periods. And then lastly, the ENSO forecast indicate increased probability of El Nino conditions by next fall. So with that, I'll turn it back over to Amanda.
All right, thank you, Julie. With that, I'm going to pass it over to our next speaker, who's Justin Huntington, who's going to be talking about the vegetation changes we've seen with all this precipitation and the outlook for spring and summer.
Hi, everybody. I think you should be able to see my screen. Hello.
Yes, you're good, Justin. We can see.
All right, let me switch this. All right, so thanks. I'm going to be talking about observed vegetation changes in spring-summer outlook. This opening photos from the Red Rock Mountains are showing all the beautiful flowers in the area. This was my old backyard. I was born and raised in Las Vegas, so definitely a sweet spot for me. Little outline here, background on plant available water, just to give some context of the vegetation changes we've seen over the last couple of years and what we've seen this year so far. What all this extra water means for vegetation, and talk about current conditions and possible conditions this growing season, and just highlight some snow cover temperature and evaporative demand anomalies and possible conditions for crops and range forest vegetation this year, and then possible flooding of ag lands. So this is a photo of a trip I took to Denver and flying across the Great Basin. This is Dixie Valley, Edwards Valley, and Smith Creek Valley that you can see off in the distance. And each of these valleys are just chock full of water. Something I've never seen before, these dry plies just full of water. Definitely a really neat thing to see. All this extra water is, of course, great for rivers and streams, but what about the vegetation? How does the vegetation respond to such an event like we've seen so far? And it really depends on the plant available water and type of vegetation. So the rooting depths, the soils, and also the water sources. So for trees and grasses, we have deep-rooted versus shallow-rooted type systems, and also whether these systems are mostly rain-fed or snow-fed, and also stream-fed, so like riparian vegetation next to streams and rivers and wetland areas, meadows, etc., that have access to groundwater-dependent ecosystems. And then, of course, we have the crops that are also deep and shallow-rooted, depending on the crop type. And, of course, we irrigate crops in California and Nevada, not enough rain. But different levels of irrigation frequency and drought tolerance result due to these differences in rooting depths depending on the crop type. So things to keep in mind, and I'll just touch on a little bit further. So plant available water can be very different depending on the plant type, as I mentioned. Here's a figure just showing some native grasses and forbs and you know, very different rooting depths, which result in different tolerances of drought, of course. And then we have phreatophytes or groundwater dependent ecosystems with phreatophyte vegetation that survive on the groundwater and capillary fringe. So while the non-phreatophytic vegetation that we can see here in the foreground may be very susceptible to precipitation changes and drought, these groundwater-dependent ecosystems that rely on the capillary fringe or the phreatic surface of the water table, they can get away with many years of drought, and you'll see persistent green vegetation in these areas. So something definitely to keep in mind when we're looking at vegetation changes with drought. And so with trees, I've always kind of been somewhat perplexed going, how do these trees survive with such shallow soils? You'll see big trees growing right out rocks. So there's been quite a bit of literature on this, and in the Sierra, at least 70% of the water used by forests during the growing season is extracted from weathered bedrock and bedrock fractures from at least 12 feet deep. And they've determined this with isotopes, so fairly robust methods to talk about and discuss just where these big trees are getting their water. And basically this unsaturated zone in this fractured rock zone stores twice as much plant available water by virtue of its greater thickness as compared to the soil layers, because there's not much soil horizon in these mountain block environments. So with crops, alfalfa has the deepest root depth, 10 to 20 feet. And of course, there's a lot of crops that have much shallower roots. So this also really affects the drought tolerance. And we can see this very clearly using Landsat satellite imagery for Lovelock, Nevada. This is on the I-80 corridor in western Nevada. And you can see 2011 is a wet year. 2013, we started going into a dry period. 2012 and 13 were, of course, dry. And you can start to see the decline in vegetation greenness here, where irrigators were not irrigating their fields. And then by 2015, there was not a single delivery of water to the Lovelock Irrigation District, but you can still see some green patches, and the depth of water is about 10 to 20 feet here. So these alfalfa crops are surviving off the capillary fringe, and they're very resistant to drought, basically. It's interesting in the rangeland landscape to see the differences in drought tolerance. So this is in central Nevada. This image on the top shows kind of the left portion of this image shows some high elevation above tree line grass type areas, whereas the right part of the image is mostly pinyon juniper, and of course there's some riparian areas along the creek bottoms. This is a 2015 growing season percent difference from average derived from Landsat normalized difference vegetation index. Percent difference from average, and what you can see is that of course this is a really dry year, and what you see is these riparian communities, grasses and forbs were really hammered because there's no water in the creeks, and the pinyon juniper uplands, this red area here was not as impacted because of course they have deeper roots that are in the fractured bedrock, and then up here, this green area above tree line, we did get quite a bit of summer rain this growing season, 2015, and these grasses really responded to that summer rain. So just lots of different dynamics and responses and tolerances to drought, and it's important to kind of think about these differences in rooting depths and plant available water when looking at this kind of stuff. So current vegetation greenness anomaly for basically the last 2 weeks. This is a MODIS percent difference from average greenness, and basically higher than average precip and temperatures led to greener than normal conditions across much of the West. So green is greener than normal, and you can see that we're up to, in some places, 400% of normal greenness, percent of average greenness. And a lot of these red areas, most of these red areas, in fact, in the mountains, are due to snow cover and also open water, in which NDVI goes small or even negative. So we're working on a way to mask these snow and open water areas out so it's less confusing. But these images were created with a new climate and remote sensing cloud computing application being funded by NIDIS and others called climateengine.org, such that users can easily visualize and download remote sensing based maps like this. So a lot of flowers, as Dan mentioned. This is and the Borrego Desert State Park. This is a MODIS NDVI percent difference from average here, and you can see just, tons of green vegetation, and that red box is the state park, and you can see the response being picked up by MODIS, and that red blob there is the Salton Sea. So nothing to take home from there, but very, very green vegetation across Southern California and most of the West. And of course, the warm temps and higher than average evaporative demand has led to this greener than normal vegetation condition. Dan touched on this. To the left is a temperature difference from average map for roughly late Feb to mid March, and then this is the right is the evaporative demand drought index, the EDDI that Dan showed for the basically the last month. And then this is the MODIS land surface temperature anomaly from mid-Feb to mid-March, which follows the air temp and evaporative demand anomaly as well. It's really quite interesting to see how warm central Nevada has been, and that translates into some high snow lines, which you can see here on the right. So this is the MODIS normalized difference snow index difference from average. Basically, areas in blue are higher than normal snow cover. Areas in red are lower than normal snow cover. On the left is where we were at in 2015, which is, of course, dire. But you can see on the right there, that area in central kind of eastern Nevada where we've had really high land surface temperatures. You can see that's part of the reason why we've had high land surface temperatures is because there's been very high snow lines. And I might add all these little hyperlinks down at the bottom will create these maps in real time in the cloud. So wetter than normal winter, but dry and hot summer potentially. This is something that I've been intrigued by, just kind of looking at past years where we've had high winters for precip and kind of seeing what happens later in the summer. And there's not a big, there's not a big trend to take from here. There aren't a lot of years for us to look at this within the remote sensing archive, starting basically in 1984 to look at vegetation greenness from Landsat. But I looked at near Kirkwood, California, 1986 basically tied with 2017 so far with total precip from January 1 to mid-March. And kind of what happened later that year in 1986 with respect to vegetation greenness anomaly. And basically you can see here on the right that it was greener than normal conditions over much of California and Nevada. Again, these red blobs are open water areas, so don't get confused with that. But basically higher than normal greenness, although there are some red areas in there. It was slightly warmer than normal in 1986. So, this potentially dry, hot summer that we've talked about so far happening this year could lead to stressed, shallow-rooted vegetation, i.e. the rangelands. And just kind of looking at it from an evaporative demand perspective in 2015, which is, of course, a really dry winter, we had near normal evaporative demand in the summer, but in 2016, when we had a near normal winter, we had higher than evaporative demand. So again, something to think about. Just because we have a very wet winter doesn't mean that we'll have very healthy rangeland conditions if these dry, hot conditions persist. Or happen, actually. So here's an experimental evaporative demand forecast that Dan McAvoy has been working on, where we take CFS forecasts and compute the reference evapotranspiration as a function of solar radiation, temperature, humidity, wind speed, And like Dan and Julie showed, this summer could be higher than average evaporative demand, but there's quite some uncertainty that exists there. Potential flooding. This is a big issue right now within the Lahontan Valley, Fallon area. So Governor Sandoval was just meeting with the general manager of the Truckee-Carson Irrigation District, Rusty Jardine, last Friday, getting an update on the potential for flooding. Basically, they built a emergency spillway and canal off the V-line canal west of Fallon, Nevada. And the idea is that they are discharging over 1,000 CFS into this canal that they just built in the last month, this emergency spillway canal. And they're basically diverting this water out into the desert and to what they call the Carson Lake, which is shown here on the left. So this is an image, a Landsat image from June of 1984, which is basically the last time there was a big flood potential from snowmelt. And you can see in June of 1984, the whole Humboldt Sink was full of water. It spilled over and it spilled into the Carson Sink, which is a really rare event. The Carson Sink is completely full of water here in 1984. But this is kind of what's happening right now is basically we need to get rid of 2 full reservoir volumes in Lahontan to accommodate what's expected to come down. And Julie showed about 600,000 acre feet of water expected to come down. And Lahontan can hold about 300,000 acre feet. So we need to flush basically 2 reservoir volumes out of here to accommodate. And to do that, we need to get rid of a bunch of water quick. Otherwise, a lot of these farmers are going to be underwater. So they're working on it, and it looks promising. And let's hope for the best. So anyways, vegetation response to drought is different depending on the plant available water, the root depth times the water holding capacity. Current vegetation conditions are above normal, and outlook looks pretty good. But this outlook could change quickly, as I mentioned, during the growing season due to the shallow-rooted plants if little precipitation occurs during the growing season. Temperature and evaporative demand forecast showed normal to higher than average conditions this growing season. And there's potential for flooding in ag areas with warmer temps, high snowmelt rates, and little reservoir storage. So that's all I have, and more than happy to answer any questions.
All right, great, Justin. I'm going to switch now to questions and answers from all the presentations, but there was one specifically for you. It was, why does Ansa Borrego seem to have all the flowers?
I don't think it's limited to just that state park. There's a lot of wildflowers right now. Death Valley, a lot of flowers in the southern part of Nevada and California right now. Just it's a pretty common occurrence when we get a lot of wet conditions like we've had this year.
All right. Thanks, Justin. I'm going to give everyone a chance to type in a few more questions before we do. There's only one other one we have right now, but if there's any other questions. First, I just wanted to say thank you to all our speakers. I know we're at the top of the hour, but we'll be staying around for a couple questions. But all these slides and the recording and a 2-page summary will be available on drought.gov later this week. As I said, this is part of a bi-monthly series. So on May 30th, it's usually on a Monday, but because of the holiday in May, we're doing our next one on Tuesday, May 30th. Will be the next update. And feel free to contact me or go on drought.gov for more information about the California Nevada Drought Early Warning System, which a lot of the presenters today are all part of. And with that, I'll go to one. Our other current question we have is, why is the ENSO chart not showing the top 2 years of precip above 2 degrees C, which is one of Julie's figures?
So I believe this is talking about the figure that I showed at the end. And so this was just for Southern California, one of the divisions. And so it wasn't for the whole state of California. It was also only for December, January, and February precip, and I did that so I could include this current year, 2017, because we don't have the March totals in for the month yet. And so based on that, it's specific for Southern California, for DJF, and that's where the data is. If we looked at the entire water year, it would, and for the entire state of California, that would change it slightly. But those are the reasons why.
Okay. It doesn't look like we have any questions, any remaining questions. So with that, I can wrap up the. Oh, there we go. One more, maybe. One more question, which I'm not sure. Maybe one of these speakers can talk a little bit about. But can you speak to fire hazards in SoCal during a warmer summer? I don't know that quite any of our experts could specifically talk to that.
Well, I think there's definitely potential for fire hazard in a year like this when we have a lot of fuels due to the higher precip and higher vegetation productivity, and you know, if we go into a dry spell this summer, which of course, you know, is a normal thing for us, right? I mean, Mediterranean climate, typical dry summers. But if we go through a kind of a heat wave and a drier than average summer, that could definitely lead to higher than desired fire danger.
All right, thanks, Justin. And I'll mention that we were starting to gather speakers for the May 30th webinar, and that was one of the topics that came up at the time of year starting to look at fire hazards. So we're hoping to find a speaker for that for the next webinar as well. I guess with that, since we're not getting any more questions, I'll go ahead and end the webinar. You can find all this information on drought.gov, and April 1st is a major deadline in the water year in California and Nevada. So a lot of these things will be updated, and you can pay attention to our resources and other resources to think about that. So, all right. Otherwise, thank you, and have a good day.